you. Yeah, thanks for the invitation and allowing me to present here. Yeah, as Matthew said, this kind of goes in a very similar direction to what Abe already presented. It's another way of visualizing workspaces. It's just, yeah, having chosen a slightly different approach. And I want to start giving a bit of historical context of how this came about. So this whole project I started as part of a effort of combining analyses within Atlas. And the initial idea of this combination was that such a combination should, in principle, be straightforward, as all analyses have been scrutinized in detail by the collaboration already. But then, of course, always reality sets in, and it doesn't quite work as easily as it was expected to. So what basically happened was that we collected inputs from the individual analysis teams, which we then wanted to combine. The issues with this are that these inputs are produced with various statistical frameworks, and then often had to be converted into the pyhf JSON format, since we use pyhf for the combination. And of course, before actually performing this combination, we had to understand and validate these converted workspaces, which turned out to be very time-consuming. And here on the right side, I just listed a few examples of issues that we saw. So for example, in some of the workspaces, parameters were fixed when they should not have been. Or in some of the workspaces, we had additional systematic uncertainties on the luminosity, which led to double counting of uncertainties. But then we also had cases of certain systematics just missing completely. And these issues can be very hard to spot when you're not familiar with the particularities of certain workspaces. So the idea that I had back then was to streamline the validation process to make sure that really the workspaces that we do combine are correct and contain all the information that we need. So now giving an overview of the Workspace Explorer. So as I said, the idea was to provide an easy-to-use interface for analyzers to validate the JSON workspaces. And I'm linking here to the website where this is running. This is running in any web browser and provides visualizations of workspace contents, and just a few of the plots that you can get I'm showing here on the right side, but I will take you through an example later on, so I don't want to discuss this in detail now. And then also, so these plots are all produced in the front end, so to make it as lightweight as possible. But then also, I provide a connection to a Python-based backend, which is running pyhf and cabinetry and allows retrieving fit results as well. So to also make it possible to compare these. And yeah, workspaces can be loaded from local files, but also provided directly from HEP data entries. And then all the plots that are produced can also be downloaded, currently only as SVG though. Okay, and yeah, the first thing that you will see when you open a workspace on the website is this kind of summary, which just lists all the processes that are included in all the different regions. And then also, since I mentioned before, we had issues with some of the normalization factors being free-floating or fixed when they shouldn't be. This is just to help getting a quick glance of the parameters that are included in the model. And then this is a plot that Alex also showed earlier in his presentation about cabinetry, giving the modifier structure of the model and allowing to quickly understand which kinds of parameters are included in the workspace as well. And finally, I mentioned there's a connection to a Python-based backend that allows running the fit as well. So we can also visualize these fit results as pull plots and also as a correlation plot. Yeah, some more of the technical details. So this is about the structure of the application. As I mentioned, the visualization runs entirely in the front end. It's written in TypeScript, and say the business logic kind of is based on Vue.js, and then using different frameworks for the state management and for some of the UI elements. And then really the plots themselves are just created from native SVG elements. And then workspaces can be sent to the backend via a REST API. This backend is hosted on a certain OpenShift instance and runs a Flask web server. So you can post workspaces there and then get the fit results. And yeah, I think I mentioned it runs simply a very simple script of pyhf and cabinetry. The code is publicly available both for the front end and for the back end. And just some usage scenarios. So the initial idea when I started this project was that we would use this to validate the workspaces that we got from the analyzers, but also to allow the analyzers to themselves, validate the workspaces they produced before sending them to us. And then it turns out this might actually also be quite useful if you want to explore unfamiliar workspaces and gain an understanding of the contents of workspaces from an outsider's perspective. And what might also be of interest is kind of taking this towards education and introduce newcomers to key concepts of statistical analysis. Obviously, those of you familiar with Vue browser will see that there are a lot of parallels, but really here the advantage is no need to set up root, and this completely runs in a web browser. So really it has a very low barrier to entry, and it ties in directly with HEP data in the sense that you can either just provide the ID of a HEP data entry that has a workspace attached, or just directly access it via a URL parameter. And then I want to quickly talk about a experimental feature. So this is not yet available in the on the official website, which I don't remember who gave me this name. I think it might have been Alex. It's called Pulling the Pulse. So basically, you can see we have the pull plot here, and what you can do with this new feature is to interactively pull on these points and see how this affects the post-fit plots instantly. This is still work in progress, and I'm sure there's a few bugs in there still, but I've linked a preview here to play around with if you're interested in this. And I think this can be really interesting to allow you to investigate the impact of nuisance parameters and kind of do the fit by hand. And this feature kind of also is included in this merge request that I have open for these interactive pulls. So I'm adding these systematic data comparison plots that just also give you kind of a visualization of the impact of systematic uncertainties or their behavior in general. Before I get to the conclusions, actually, I want to try to give you a quick demo of the site. So let me just quickly open it. Oops. So this is what you will see when you open the site for the first time. This is now from this experimental branch, which is not yet in the main website, but you can access it on this URL. I provide an example for everyone that maybe doesn't have a workspace at hand. So if you just click on try an example, it will load this workspace, and you can see right away this summary that shows you all the different processes that are included in all the different regions, and then the normalization factors, as I mentioned. Before I show you all the plots, maybe you can quickly go down here, and you can see if you want to fit this workspace, you just click this button, it will be sent to the backend, and then run while I can maybe show you the other features. So yeah, this plot I also already showed. This kind of gives you an indication of how important the different processes are in the different regions. And you can see it's kind of interactive, so it nicely highlights which processes you're currently looking at. And also plots are immediately updated when you, for example, want to change the color. So yeah, this all instantly updates as you go. Yeah, I mean, then of course we have the pie charts. We have the data Monte Carlo comparisons. All of these, yeah, react to. And then the I think most useful plot actually the modifier structure, which makes it really easy to explore which nuisance parameters or modifiers are included for which sample in which region. And you can see this is actually quite helpful when you want to identify maybe stray systematic uncertainties that are included that should not have been. For example, here we have this luminosity parameter, which double counts the luminosity uncertainty that is included in the model anyways. So these are the kind of issues that you can easily identify with this kind of plot. Yeah, and then we have these systematic uncertainty charts, which show you the size of the systematic uncertainties. These can be filtered by name. So for example, if you want to see only the uncertainties on, say, the TT bar modeling, you can just filter, and it will only show the modeling uncertainties on the TT bar process. And then finally, you can see the fit has finished, and we get the pull plot and the post-fit plots, and also the correlation matrix. Right, and then the new feature that I just quickly wanted to showcase is this pulling of the pulls. And yeah, basically you can just grab one of these data points and pull them around, and you can see on the right hand side the post-fit plots update instantly. So as I said, this is still quite experimental, but I think it can be quite interesting to play around with them. Yeah, I think this is all I wanted to show in the demo. So I'm switching back to the slides. And yeah, going to the conclusions now. So I've presented another way of visualizing HIST factory workspaces in the browser. So this allows reading local files, but also loading directly from HEP data. And it provides a connection to a backend that runs pyhf and cabinetry, so you can also run the profile likelihood fits. And I think it's quite useful for understanding statistical models and also sharing them and making the visualization easy. And then I just showed you in progress, we have these interactive pulls and also the plots of the systematic variations, and some ideas for the future that have been brought up. And this again goes kind of in the same direction as what Abe showed before as well, is that it would be nice to be able to cache the workspaces and fit results on the server, and then to allow sharing them via permalinks, and also being able to exclude fit parameters, for example, from the profile likelihood fit. But yeah, if you have other ideas and input, I'm of course open to any suggestions. And then, having said all that, I have one last slide, which is not really in the scope of this talk, but I figured it fits the workshop, and that is the combination effort which was the basis for this project. We just last week made the code that we used for the combination public on GitHub, so I wanted to share this as well. It's based on pyhf and cabinetry and makes it quite easy to combine workspaces by just providing configurations for the input analyses and for the overall combination. And I just put screenshots of the configuration files here as to give a quick idea of how these things work. And yeah, you can get these nice plots of the combined limits compared to the individual workspaces in the end, which I think are quite neat. And yeah, that's it from my side. Thanks.
Nice. Yeah, very cool. So thanks for that great presentation, Volker. So let's see, let's go to Zoom to see if there's any questions. So I don't see any hands raised yet, but Jordan has a question, so we'll go to Jordan.
Do you mind going back to slide 8? That's the right one. Next slide. I think it's 9. Yeah. So this link that you have here on the bottom. So you mentioned, loading a workspace by the HEP data entry. Would it be possible, instead of using some generated ID that you have on the server, to just have the URL include the HEP data identifier? So that way someone could just put the link knowing the HEP data identifier or the DOI identifier for the hitchback features on workspaces and automatically load the Explorer from that.
So I'm not sure if I understand correctly, but is this going in the direction of what I have here as the second point? So basically what I did here is just giving the HEP data ID as a URL parameter to the to my website basically, and this will automatically load the workspaces connected to the HEP data entry with this particular ID.
But the ID is not the HEP data ID.
It is.
Oh, it is.
Yeah.
What is this? Multiple workspaces?
It should load all of them. Let me just try. I hope it still works. I haven't tried this in a while actually.
Well, because HEP data IDs are typically an Inspire record number. That's typically how they do it. So I expect to see INS, and they're only 7 digits. I see 8 there, so I guess I got confused.
Right. Is it 7? I think this is just the
7, never mind. Yeah, that is
yeah, and it loads all the, like in this case, it has 4 workspaces attached, which are then all loaded, and yeah, you basically have one entry on this site now for each of the workspaces. Again, it also only works, like in Abe's case, also it only works if the workspaces are directly attached, not if they are tarred or lit or whatever.
What does directly attached mean in this case?
I mean, I don't know how HEP data works exactly, but like if you have one attachment for each of the workspaces, then it just loads all the attachments. But some HEP data entries have just one tarball of multiple workspaces, and it doesn't unpack these tarballs yet.
And I guess it doesn't handle the patching, right?
Exactly.
Yeah, this is the thing. The HEP data team has been reluctant to provide a clear standard on how to do this, but it's also something that still needs to be thought of. Atlas has just kind of decided we'll put everything into a tarball, and the tarball contains the README with the patch sets and the background only. At least Atlas has been consistent about doing that. And then HEP data will just look at the names of tarball to determine if it is a probability model or not. But HEP data is not actually analyzing the contents. So you could upload a tarball that doesn't actually contain any probability model and give it the right name, and HEP data will mistakenly identify it as such. It's something that's tricky because it's not clear whose job it is to define the specifications here for how that should look when you upload a HEP data.
Did it load multiple? Like this shows up as 4 entries in HEP data? then I'll like load all for workspaces.
Yeah.
Ah, yeah, here you go. Ah, okay. And then the ID matches HEP data.
Yeah.
Okay, so I don't see any other questions on Zoom. Do we have any questions in the room?
Do you want to open it up to questions about anything from today since we're towards the end?
Sure. Actually, I have one question related to this though. So on slide 7, you showed the like application structure. So, right. So though I know quite a lot about Python packaging, I know absolutely nothing about how web application packaging goes. So is this currently running on like CERN OpenStack, or where like this is running at CERN, but how is this running at CERN and where is, so you have these front end elements that are all running, but is this on OpenStack?
Yeah, it's also on a OpenShift instance. Yeah.
Oh, OpenShift. Okay, sorry. I always got, yeah. So it's on, so this is running on OpenShift. Is it possible, like, is it possible to distribute this as like a collective JavaScript package, so you could basically do like you know, some sort of installation of the entire thing on any server, or is this something that like kind of requires a little bit of experience to set up correctly?
I think it should be relatively straightforward to run it anywhere.
Okay.
I mean, I got it to run, and I really am not a web developer of any kind. So.
Oh, okay.
This is the first time
well,
I ever.
Well, you wrote this, so you fooled me. So.
You might be asking, you could package this up as TypeScript and then do a transpilation of this. I've done web for 20 years, so I know a lot.
Well, yeah, I guess I'm kind of wondering, like, when I see this, I'm like, oh, if this is all these things, like, could you, like, is it too wild to try and like think about making a Jupyter Lab plugin with this, so that you could basically have Jupyter, like in your Jupyter Lab, you could open up a window, and similar to how with Dask, you can do all these visualizations of your Dask cluster, could you like do visualization of your workspaces in Jupyter Lab natively using this?
So Foo doesn't work with Jupyter Lab, that's the thing.
Wait,
You
what?
rely on Foo to generate a UI, right? So that's gonna be the hard part to pull out. Foo kind of locked into an ecosystem here where you can Foo with both the back end and the front end here.
Oh,
Vue. Yeah,
okay.
Vue is you can think of it as like Node, but a little bit nicer. It gives you some sort of like real-time feedback. I guess it depends on how much of this is your custom JavaScript that you can pull out and how much of it is tied into Foo. Because Foo kind of encourages you to throw things into its own structure, and that makes it hard to pull out.
I think that's most of it, though.
Okay.